Hello friends, welcome to my YouTube channel. In this channel, specially I upload videos related to math of class 11, 12, BCom, BSc, engineering and higher class also. If you like these videos, please subscribe my channel and like and share. Okay. Now we are going to discuss a trigonometry related chapter, submultiple angle. The problem is sec phi plus alpha sec phi minus alpha equal to 2 sec phi. Then find the value of, then show that cos phi equal to plus minus root 2 cos alpha by 2 root 2 cos alpha by 2. Okay. First of all, we have to convert sec into cos 1. As we know that sec theta equal to 1 by cos theta. Taking LCM, we get cos phi minus alpha plus cos phi plus alpha divided by cos phi plus alpha into cos phi minus alpha equal to 2 by cos phi. Okay. Cos c plus cos d. 2 cos c plus d by 2. Finally 2 cos phi into cos c minus d by 2 cos alpha. Cos a plus b into cos a minus b. It will be cos square phi minus sin square alpha. As we know that cos a plus b into cos a minus b is equal to cos square a minus sin square b. Okay. Equal to 2 by cos phi. Therefore, cos square phi multiplying cross multiplying these two, cos square phi into cos alpha equals to cos square phi minus sin square alpha. Okay. Therefore, sin square phi alpha is equal to cos square phi minus cos square phi into cos alpha. Okay. Rearranging the term of this relation. Therefore, sin square alpha equal to, taking cos square phi as common from these two, 1 minus cos square phi into bracket open 1 minus cos alpha. The submultiple formula of 1 minus cos alpha is 2 sin square alpha by 2. Okay. Therefore, it will be, I think, 1 by root 2. Okay. Not 1 by root 2. Only 1 by root 2. Sin alpha means 2 sin alpha by 2 into cos alpha by 2. Distributing the power, we get this 2 cos square phi into sin square alpha by 2. After cancelling 2 sin square alpha by 2, we get cos square phi equal to 2 cos square alpha by 2. Therefore, cos phi will be plus minus root 2 cos alpha by 2. Okay. Very easy to solve. If any doubt arises, please comment me. I will clear your doubt. And thank you for watching this video till now. Okay.